Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright, I got another thing that came out of my storage center. Another nice find. I knew this was in there. This is one of those things I was waiting to pull out of there. It's a power oscillator. Maybe you've never seen one. This is from, it says Powertron. We'll clean it up, take a look at it. But this thing is pretty darn cool. Now, why do you need a power oscillator? It puts out a frequency range in the audio band, and it goes up to 130 volts, I believe. So here's the thing, with something like this, you can test, like, let's say a speaker crossover, because now instead of just putting a small signal generated, signal through the crossover and watching the frequency response and all that, well, that's all done with no current going through those components. Low level signals, they just don't activate those power devices like they would if they had current going through them. For instance, the inductors. That magnetic material, ferrite, whatever you have in there, iron core, is going to behave differently when it has current going through there. The inductance is going to change. It's just going to behave different, right? And possibly the capacitors. So with this, we can, I think that might be one of the first things I do with this. I think I'll do a video where I look at a speaker crossover and see how different it is compared to, say, just my generator, my signal generator going through it. Okay? But hey, let's take a look at the specs of this thing. Okay, it's a Powertron Model 5900. Has bipolar and FET technology, which is pretty cool. Has 3 output ranges: low range, middle range, and high range. The low range can go up to 8.5 volts RMS at 8.2 amps. The middle range goes up to 38 volts RMS, 1.8, and the high range goes to 130 volts at 0.53 amps. The regulation, line and load regulation, is 0.1%, so it can hold the signal pretty well, it looks like. Distortion's 0.3%, and that's in the mid band. I don't know what the other bands are, but that doesn't seem too bad for a power oscillator. And output power, max 70 VA, but continuous, it can do 50 VA. So if we're not going through inductive or capacitive loads, that means 70 watts or 50 watts, right? But because we could have reactive loads, they call it out in VA. Frequency response is 45 hertz to 20 kilohertz, and frequency accuracy is 0.1%, which is pretty darn good. And dimensions is 12 1/4 inches by 5 1/4 inches tall and 12.5 inches deep, I believe. Or maybe that's across. I'm not sure which one. But 12 by 12 by 5, roughly 23 pounds. So it's a girthy guy. I mean, look, it's got some weight, and a lot of it's over here in this corner back here. Let's bring the camera over and open this thing up, and well, I'll spin it around and kind of show you. But it seems to be made really well. I like the dials, the knobs on it, and it has the gold banana jacks. They look nice and solid. So let's get a closer look at this thing. Alright guys, so this is our Powertron, and we have some nice gold plated terminals here, power switch with the light. This meter got broken, I think, in transport probably. The little needle, it was all bent when I tried to bend it down, it broke off right here. But yeah, obviously the plastic shield's gone, so that's too bad. But yeah, it has a high and low output connector with the ground. This ground is connected to all the metal things. I own that out. Range for frequency is high and low. Then you adjust, and these feel like nice pots. These are kind of like a hard plastic or metal. I think, I'm not sure what they are, but they're nice. And here's our ranges. There's 130 volt range, 38 volt, 8.5, and a 0 volt. And then same kind of nice pot here. And this meter should tell frequency, and that's the voltage reading. So yeah, that's what that looks like from there. Then, here, let me just roll it over so you can kind of see what it looks like. All right, so there's a side view. These knobs are nice. They tighten down so you put this handle in different positions. I'm thinking this is all kind of metal. So there's a top, needs to be cleaned up. Had stickers on it, probably calibration stickers and stuff. And then, yeah, knobs on both sides, same kind of knob. Looks like 2 screws to hold these end plates on both sides. Had the 2 screws, nothing on the top, and there's the bottom. Has nice rubber feet that are screwed in like that. And something else that's something heavy there. That might be a transformer, I'm not sure. We'll find out when we open it up. There's the handle, it's kind of tightened in place. Let me show you the back. I hear something sliding around inside too. So it says regulation. This screw is holding this tight, so that must be for calibration, and then you can tighten that up. Then our fuse, of course, our cord that's just soldered directly in there, and Industrial Test Equipment Company. Okay, then I'm going to hold it so I don't put it down on its top, on its face. But we have 2 big power transistors on this big heatsink back here. And yeah, there's definitely something loose going around inside. And then there's the top. And this little plastic part was cracked and chipped. And this part's plastic, these 2 end pieces. So yeah, maybe I'll try to glue that back on. But yeah, there we go. I'll clean it up. Let's open it up. Alright guys, so here's the handle. That rubber's still nice shape after all these years. I'll clean this up a little bit. These knobs held it in on the side. You know, nice hardware. And then there's the 4 screws on each one of the frames. It's kind of dirty, so we'll clean that up too. And this is the one that was off the top that kind of got chipped, so see if we can take care of that one too. And I see all these screws around the faceplate still here, but this kind of feels loose. Oh good, I was hoping that was going to come off. Okay, nice shielded cover. Wow, that's pretty cool. Alright, so there's a better view. Big resistors, aluminum caps look like they're in good shape. Transistors are interesting because they're on these heat sinks, but there's a gap. Here I can put the screwdriver underneath them. You can see there's a gap. So the heat has airflow around it. That's pretty cool. I haven't really seen that mounting technique. Okay, we have some LM310s. Not sure what they are. I'd guess op amps, but not sure. Wow, look at that huge bus bar. That's gigantic. Big chunk of copper. And these caps are Sprague. You can see the Sprague caps down there. That was a good brand back in the day. See these edge card connectors with the gold plates? I'll have to maybe clean those. And just looking down here at the other side of the box, we see a transformer here for probably some housekeeping voltages, and then we got the big old girthy guy right here. Yeah, that's pretty big. These 2 terminals soldered together with this wire. I don't know if you can see this little I-beam kind of shaped thing. It's kind of a U-channel actually. This down here, this aluminum thing that goes across the bottom. Looks like there's some bars that go across on the other side too. We'll have to flip it over to see if we come off the bottom part, but yeah, there's the light down there, our switch, and our meter that we need to replace. And here, let me zoom in. It's kind of interesting. You can see the 7-segment LEDs down here on the board, and some other circuitry there. Alright guys, I turned it over and the screw came out, so at least found what was rattling around inside there. Alright, flipped it over hoping the bottom would just come off, but I had to loosen these screws. The interesting thing is these rubber feet are still held down. Maybe they're with stickers, but oh, maybe I have to do these screws too. Guys, I took these 2 screws off now. I think this cover wants to come off. Yeah, looks like it come off now. I'm gonna lose those screws, but yeah, just another nice piece of aluminum shielding. Okay, so it looks like those 2 screws were helping hold this board down. Looks like some of the stuff's not soldered on, from at least the view from this side. Okay, so maybe you can see it looks like some things not soldered in place. That's an interesting pot right there, or that gang switch. You can see that. Pretty cool looking. Nice Borns pots. Always liked the Borns pots. Yeah, really nice pots and switches back here. And there's our gold connectors. And we'll probably find where that screw goes eventually. Here's the side of the I-beam where the transformer is mounted to and everything. Transformer's right here. Something else is mounted on this side. So, looks like nice Teflon wiring with a bunch of zip ties. I'd almost expect nylon ties, but they all seem to be still in shape and holding on, so that's good. Okay, so I removed the screws from the front plate holding these brackets down. Now it looks like I can move it around. Maybe even disconnect it from that. There we go. So there's a close-up of the board. It says these caps are surge rated. 47 microfarad, 50 volt. That's really interesting burr brown chip right there. Okay, back side, nice shielded cable here. Okay, let's take a look at that board at the bottom. Okay, again, the aluminum caps look like they're in good shape. Actually, everything's so clean inside. I'm really impressed how clean things are. And I think these are power op amps. They're on heat sinks, pretty interesting. Here's one not on a heat sink, and then it looks like there's place to mount one here on the board. Big old carbon resistors. Another one right here with a different type of heat sink. Yeah, pretty interesting construction. Still don't see where that screw goes. Oh, I found it. I was looking all inside the box, and here it is here. The display board. Pretty interesting, right? Big old intersil EEPROM probably. And a crystal over here. Yeah, and again, another one of these nice electrolytics. But yeah, there's one screw right here missing. I was just looking to see if there's anything like shielding that was missed out because of that not being connected, but it doesn't seem to be. It's just a mounting spot. Alright, I installed it, and you know, I checked these other screws, they were tight. I've looked around the cabinet, and everything seems to be nice and tight and snug inside, so it's just interesting that one screw found its way out. Just wanted to show you how they mounted those caps and that bus bar a little closer. I also wanted to point out the quality of these pots. These two here are totally sealed. This one is a selector switch, but really nice designs. Sealed up, kept nice and clean. The switch down here is totally sealed. Let's see if I can get a picture of that one. As well as the power switch. You can see the back of it. It's all sealed. So they use nice quality components in this thing. this transformer over here is a work of beauty as well. It's nice black. It's looks like the day it was built. Just pointing out some of the build construction. See this cable? It's a little longer than what it needs to be. Well, I guess there's some wires coming into this harness right here from the transformer. But you can kind of see how once you disconnect this guy, I want to be careful not to break things because of age, but everything feels like it's in good shape. But you can kind of see how the thermistor, and there's some resistors, and the transistors mounted on the back of this, they're all harnessed together like this and make this one single connection to the rest of the box. Pretty nice. And then if you look down here, the capacitor resistor is probably a discharge resistor, and the capacitor is a ceramic there, a film here. So this input circuitry, the fuse and everything, that seems like it's all been taken care of nicely. And you can see the bridge rectifier down here and how it's all captured in this harness. They just did a really nice job. See the caps down here, the harness going between the caps down here at the bottom maybe. But yeah, you can just see this harness was put together really, really nicely. So when you have a system like this with a lot of wiring, it's really nice to see when somebody goes to the trouble to make sure everything is dressed nicely, that it's all, the wires are where they're supposed to be and everything's captured nicely. And you know, the power cord, I like to just point out, it's a 3-wire 18 gauge wire, but yeah, seems like it's in excellent shape. Pretty unbelievable for the age of this thing. Okay guys, I've taken the one out on the right side, and again, it is a Motorola MJ802 with the number 50 written on it. I think they match these transistors. It's marked with the 50, so I'm wondering if they matched or they checked the beta on it, but it's MJ802, an old Motorola transistor. This was on the left side, facing the rear. Now, to put these back in, it's kind of takes about 4 hands, and I only have a couple. Okay, so I'm just putting these little nylon sleeves down on here. I got this dropped into the plastic case, got the screws pushed up through, and now I'm just putting these down, and then I'll just slide it back in there. Now there's a little thermal grease, but I'm going to put just a little bit more and spread it real thinly. Alright guys, so we're going to turn on power. Let's get the meter on and just see if it all detects. Okay, we got 21 volts and 239 hertz. Look at that. That's pretty amazing. Hope you can see that hertz there. Okay, let's go to, and that's a 0 range, I think. I'm not sure why that, I don't know what's going on there, but that's supposed to be the 8.5 volt range, but okay, I'm on the high output over here. Let's switch over. I didn't see any change. Now frequency, that's 35K, and this, or 3.5K, 3539, 3540. That's pretty darn close. Just kind of winging it here. It's been a long time since I've used this. Okay, I've got this maxed out, 26.38 volts. And let's go back down to low frequency, 26.38. And it's kind of jumping around, 2257, 225. Okay, let's go over to the high. And it says 14 volts. Jeez, I really don't understand. Yeah, I don't really understand what's going on there. Okay, going 130 volt range. Whoa. I got the high voltage there. Okay, so if I max it out again. It's maxing out 115 volts RMS. Still 225. Up here is 226. Kind of goes between that and 5. Let's go to high frequency. 1729. I connect. Oh, there we go. 3535. 3535. Okay, we went to 14 volts when I went to that range. Let me go over here. Okay, I'm going to go back to the high range. Okay, I only get 27 volts there. And I get 115 there. So if I go down to the next range, you get 14 volts on that range. Again, maxed out. Boy, I would have thought I could go up to 38 volts there, so. Okay, 14 volts. Let's go over here. Okay, so maybe only on the high range that you go to the red one, and the white one, you go there. You know, here, let's try something else. Alright, now I think we're talking. There we go. You know, that was my mistake, guys. This ground is connected to chassis, which I was kind of bummed because I wanted a floating output, and it looks like it is floating. If I go to these two, you get high and low, and ground is what you'd think it would be. So it actually goes a little bit above 146.8, and then if I go there, it's a little bit above 41. If I go there, 9.8, so then there should be, and that's why the frequency is kind of jumping around too. I thought the frequency wasn't very stable, but now it seems rock solid if you notice. Here, let's go up in frequency. Okay, got 10.689 and 10.69. 10.7, so man, it is really solid. Okay, if I go there, I'm at 1K, 1021. Look at that, 1021. That is just amazing. I mean, this thing is really stable. Man, yeah, happy about that. All right, guys, you know what? We're gonna do a test with this with a crossover, and I'll do that in another video. Alright, guys, I hope you like that. I think this is going to be a very interesting piece of equipment on the bench. I've kind of missed it a couple of times, but I think speaker crossover sounds like a great way to use this. What do you guys think? What other kind of testing can I do with this thing? Remember, it's about 50 watts or 50 VA, 75 I think was peak or max. So yeah, there's some limits, but that's not too bad. I mean, it's enough to do some crossovers, I believe. So alright, guys, thanks for watching. Big thumbs up to my Patreons. You can become a Patreon, link down below. Hit the like button, really appreciate that. That helps a lot on these videos. And wow, okay, guys, I'm amazed how clean that was inside. That is pristine, right? Pretty cool. Just wish the meter wasn't broken, but we'll have to hunt for one of those. Alright, guys, thanks a lot. Yeah, it's a Hoyt electric. It says PT 1.437. I looked that up at Hoyt Electric site. I couldn't really find that meter. It's about 2 inches high and I think it's like 3 inches across or something like that. And I couldn't find anything just like it. I should have paid attention when I had the top off to see how much of a hole I had back there to play with. But yeah, we'll look at it. But anyway, we can always use a meter to back it up, right? So I did a web search to try to find a manual for this. I couldn't really find a manual. I found that spec or that data sheet I showed you. But yeah, I was hoping to find maybe part numbers or things like that. But I did find a reconditioned one. I think was, now I forget the price, $1,700 US. So yeah, they're still going for some decent dollars. So if I can't find a place for it, no, I think I can. I think this is kind of a specialized piece. I think this would be kind of cool. So, all right, thanks for watching, guys. See you next time.